Okay, so one last example. I just wanted to go through this because I see it's a very, very common mistake that happens with a lot of students. So they get to this point and they say, all right, I understand I can break it up into the square root of 50 times the square root of -1. And I understand that square root of -1 is going to equal I. But I always get a little bit confused when I'm trying to choose, what two numbers multiplied give me 50. Now, I know I could break this up. If I took 50, I know that I can rewrite that as the square root of 5 times the square root of 10. But then I don't know what to do after that. Well, part of the reason is your product that you have equaling 50, neither of these are square numbers. So when you're simplifying your radicals in this method, we have to make sure that we're only breaking up into a product where one of our numbers is a square number. And I'll just go through the first couple square numbers for you. 1 is not going to matter. 4, 9, 16, 25, 36, 49, 64, 81, 100. All right. So when I give you a number and I say simplify the radical, we got to make sure we pick one of these values and the largest of these values to divide into 50. So therefore, when we're going down the list, 5 nor 10 is a square number. So breaking it up into this is not going to help us simplify. It's just going to help us rewrite it. However, I notice that 25 does divide into 50, and it goes into 50 twice. So now, that's not 50. It's supposed to be 25. So the reason, again, why it's so important to have a square number is because we can take the square root of a square number, right? The square root of 4, 2. Square root of 9, 3. Square root of 16, 4. We can take the square root of all these numbers. So the square root of 25 is going to be 5. Square root of 2 is not one of these values, so we can't take the square root of it because it produces an irrational number. And then the square root of -1 is our imaginary unit. And that's going to be our final answer, 5 times square root of 2, I. Thanks.